Hey everyone, this is the Math Nexus, and today we are going to solve the IGCSE and O-Level Admath exercise 1.5. In the previous lecture, we discussed about modulus functions, and this lecture is going to revolve around how to make the graph of these functions. Okay, so before we start, let me emphasize the three main things that are needed to plot a graph. So, to plot a graph, we need, first of all, we need to know the shape of the graph. This is not as much important, but still it allows us to check if our answer is correct or not. Okay, the shape of graph. The second thing we need to know is the vertex or the turning point. Right now, we are going to discuss about modulus graphs, so we are not going to talk about turning points because they will come in the quadratic equation. So for now, we are not going to discuss this. We are only going to discuss the vertex. And the third thing, which is important to plot a graph, is the y-intercept. Okay. And as we know, every component of the mathematical world has a equation. Similarly, an equation is connected for the modulus graph, which is y is equals to a. In a modulus, we say function of x plus c, where this c is the y coordinate of the vertex, and this a decides the what do you say? Decides the shape of the graph. So let me tell you, if this a value is positive, so the shape of the graph when a is positive, then the shape of a modulus graph would be something like this. Okay, and when a is negative, similarly, so the graph would be something like this. So it's not important to know that, but still it allows us to check if we are going on the right path or not. So you would just first take this, that from this equation we know if this a value is positive, we do know the shape of the graph. Then we will find the vertex. For the y-intercept, first of all, let's discuss the y-intercept. For the y-intercept, you would just assume the value of x to be 0, and you would find, for the example, we have this equation y is equals to modulus of x as given in this equation. If we want to find the y-intercept of this equation, we are going to just assign the value 0 to x. So we will get y is equals to 0, which is the y-intercept. So 0 is the y-intercept. Okay. So that's how we find the y-intercept. Just by assigning the value of x to be 0, we can find the y-intercept. I've said that too many times. Okay. Now the vertex. Let me tell you what is a vertex. So vertex is actually the point where two lines may intersect. Okay. For example, let's go to this example. Okay. So this is the point where this line and this line intersect each other. So this point is called the vertex. That's simply it. Okay. So how do we find the vertex of the graph? For example, now let me tell you something. In this equation, which I have written, and it's important that you learn it, it makes life much easier. Okay. So the modulus of fx in this equation, just if we just assign the modulus of fx is equals to 0, whatever the function is in the modulus, okay, in terms of x I'm talking. So if we assign that value to be 0 and we just solve it, okay, it's not important, let me erase this. It's not important that it should be in a modulus right now. Okay, just take it out of a modulus, assign the value of the function to be 0, and for example, right now we do not have an example. Let's take from the question 1. Let me see. Question y is equals to x plus 1. For example, let's say we have this equation y is equals to modulus of x plus 1. Okay, and what we do is x plus 1 is equals to 0. We just take that function out of the modulus and just assign it to 0. And what will happen? We solve that equation, x equals to -1. So x is the so this x is the x value for the vertex. So we say that the vertex is at the point -1 as x, and how do we find the y value of the vertex? So the y value is actually this c. Okay, this c is the y value, and if we see right now, y is equals to x plus 1. We cannot see any other integer or any other value here. So we assume plus 0 to be. So we say the y-intercept for the, sorry, not the y-intercept, my bad. We say the vertex point for the y value of the vertex point is 0. Okay. So we have the vertex to this. Vertex is -1 and 0. Simple. And I know it may sound a bit confusing right now. It's haywire right now, but as we solve these questions, it's going to be much more easy. So on to question number 1. Okay. So for question number 1a, we have y is equals to x plus 1 in a modulus. Okay. So again, I told you learn the equation well for the modulus graphs. Y is equals to a, the function of x in a modulus, plus c. Okay. So first of all, what we should know is the shape of the graph. Shape of the graph, the y-intercept, and the vertex. Okay. Now let's find each of these by order. Okay. So right now the a value is not in this equation, so we say assume it to be +1 here, obviously, because there's nothing here. It's an imaginary 1. Okay. So we say we have +1, so we say the shape of the graph is going to be V. Okay, it's going to be a V-shaped graph. Okay. Now second thing, we have to find the y-intercept. And when does the y-intercept come? Is when x is equals to 0. So when x is equals to 0, we are going to say when x equals to 0, y is equals to +1. So again, y is equals to 1. So 1 is the y-intercept in this question. Okay. Okay. So y-intercept is equals to 1. Okay. Now let's find the vertex. What is the vertex? Vertex, we do know it is the point at where two lines intersect each other. Okay. And then the thing is, what we are going to do is vertex here. So as I told you, we are going to take this function of x out of the modulus x plus 1 and just assign the value to be 0. So x is equals to -1. That is the x value for the vertex. So we are going to say the vertex is -1, and the second value we are going to find is the y-intercept. And if you see plus c, we assume it to be 0. Assume it to be 0. Okay. So -1 and 0 is the vertex point of this graph, and we do know these things. Okay. So we have two coordinates, -1, 0, for which is the vertex. We have the y-intercept, which is 0 and 1. And we have the shape of the graph, which is a V shape. Okay. That makes us easy, and let us go to the graph so that we can solve this. Okay, so I've just copied my two coordinates here. For this is the vertex, and this is the our y-intercept. And let us plot this graph. Wait a second, let me. Okay, so our first coordinate is at -1, 0. So -1 is here, 0. Okay. negative 1 0, and when 0 1, when x equals to 0, y is equals to 1. So and if you just draw a line from here to here, we'll just reflect it on the same gradient. That's it. That is our, and if I would explain it more specifically, is I make this from the y-intercept, I'm going to extend this line to the vertex, and from the vertex we do the vertex is actually the point our graph is going to reflect back, because it's a modulus, it's not going to be a straight line right now, so it's going to reflect from it, and from here I'm going to draw a perpendicular line, and from that perpendicular line I'm going to help us to allow make a direct reflection of our graph, and that's it. It may seem small because I have taken the graph for a large number of values, but still it's easier for me right now. I would prefer you to build it, and in fact if I just make it this, it's much more bigger right now. So that's it for question number 1, part A. Let me erase this for part B. And for part B, we have y is equals to modulus of 2x minus 3. Okay. So again, compare this with the equation y is equals to a function of x plus c. And I'm going to make it much more faster because I've explained it really a lot in part A. So shape of the graph, shape is a V shape. In fact, let me tell you that all of these questions, all of these parts in this question has a V shape because they are all positive. So I'm not going to extend this that much. Okay. Now the y-intercept. Y-intercept, we are going to say that when x is equals to 0, the y-intercept is going to be y is equals to 0 minus 3. 0 is 0 minus 3, which is equals to y is equals to positive 3. There's the y-intercept. And then the reason why I said positive 3 is because we have discussed earlier that anything in a modulus should come out as a positive. So it's going to be a positive 3. Then we have taken out the y-intercept, we have to find the vertex. For the vertex, we take the equation in terms of x, 2x minus 3, and assign the value to be 0. So it's going to be 2x is equals to positive 3, x is equals to 3 upon 2. Okay. And for the y value of the vertex, we are going to say, let me say that, vertex. And for the y value of the vertex, we are going to say the c part. And for now, the y value is 0. So we are going to say the y vertex points are at b is 3 upon 2 and 0. And the other coordinate for the y-intercept is 0 and positive 3. Shape is V shape. Let me erase this graph. From the values, we have the values 3 upon 2, 0. Oops, bad. We have 3 upon 2, 0. And we have 0 and positive 3. Okay. And what we are going to say is when x equals to 0, y is equals to 3. So it's going to go all the way up here. And when x equals to 3 upon 2, which is 1.5, so around here, y is equals to 0. So this is the point where it's going to be made. Okay, so now we are going to make a line. I think there's a problem here. Let me draw this 1.5 and add 3. Then I'm going to make a perpendicular line, and from that point we are going to make it. And then from here we are going to say we are going to directly reflect the graph at that point. Yeah, so that's it. This is for part B. Okay, so for part C, we have y is equals to 5 minus x in a modulus. Okay, so what we are going to say, we already know the shape. Let me erase the shape also. Shape all is equals to V shape. Okay, so we know the V shape. We first find the y-intercept. When x is equals to 0, y is equals to 5 minus 0, y is equals to 5. Okay, then the vertex, you are going to find the vertex, which is when vertex is 5 minus x should be equals to 0, and then negative x should be equals to negative 5. Cut down the x is equals to 5. The y value is again 0 because there is no c value right now here. So the vertex is at 5, 0, and the other y-intercept is at 0, 5. Okay. Again, go towards the graph. We have 5, 0, and 0, 5. Okay. What we are going to do, plot these points on the graph. When x equals to 5, y is equals to 0. And when x equals to 0, y is equals to 5. Okay. Make a line. From here, we go all the way towards this, and then make a perpendicular line so that it can allow us to make a perfect reflection. From here, again, we go all the way up to 5, and here we are. That's it. So this is the perfect reflective graph of part C. On to part D. Let me erase this. For part D, we have y is equals to modulus of 1 upon 2x plus 3. Okay. So again, first find the y-intercept. When x is equals to 0, we have the y-intercept. 1 upon y is equals to positive 3. Y is equals to positive 3. That's the answer for the y-intercept. And for the vertex, what we are going to say is 1 upon 2x plus 3 should be equals to 0. Similarly, 1 upon 2x is equals to negative 3. Yes. X is equals to negative 6. Yeah, and the y value is again 0. So we are going to say the vertex is at the point negative 6 and 0, while the y-intercept is at the point 0, positive 3. Now onto the graph. Yes. Okay. So again, plot these points on the graph -6 and 0. Where should they come here? And the second point is at when x equals to 0, y is equals to, oh, my bad, plotted it wrong. So when x is equals to 0, y is equals to 3, right here. And when x is equals to -6, y is equals to 0, right? Okay, now again, make a line from the y-intercept towards the vertex and make a 90-degree line to allow us to give us good reflection. And from here, wait a second. See, I think we have to move the graph a little this time. And if we say right down here, go all the way towards this. No, that's really wrong, I think. Yes, this is the graph for part E. Actually, this is not the graph. This is wrong. Let me correct this. At this point, yes. And what I'm going to do is I'm going to tell you another method for which you can have a perfect reflection for your graph in the next part. So let's proceed on to the next part. So the thing is, I did not think we would need the gradient for now, but as we are solving these questions, I think I need to introduce to you to another thing that makes life easier in drawing a graph. So we have the shape of the graph, we have the y-intercept, we have the vertex, and another new thing is that we have the gradient of the graph, which allows us to easily make any graph. So what's the gradient and what's its formula? Gradient is actually the slope. For example, if a line is straight like this, so its gradient should be, and by the way, gradient it is represented by the symbol m. So the gradient is 0. So the gradient is actually the slope. For example, for this slope, we may have a different gradient, something like gradient is equals to 3. So the gradient is actually the steepness of a graph line, actually. So that is the gradient, and the gradient formula is represented by m is equals to rise upon run. And if you are familiar with the straight line equation, which most of you should be, which is y is equals to mx plus c, we do know that c is the y-intercept only in this type of equation I'm talking about, while x is the x-coordinate, y is the y-coordinate, and m is the gradient. So if we just concentrate upon these functions which are given 1 upon 2x plus 3x plus 1, we see all of these represent a straight line equation. For example, 10 minus 2x. 10 minus 2x is y is equals to mx plus c, but it's jumbled up. For example, the m for the gradient is with the x coordinate. So right now with the x coordinate we have -2. So we directly get to know that -2 is the gradient. C is the y-intercept, so here is C because it's jumbled up right now. So the y-intercept only in the straight line case, the y-intercept is equals to 10. Okay, and that's one. And another thing is that I discussed that rise upon run. Let me explain what is a rise. So let me go. It's here good. So this is a graph, normal graph here. Okay. So the changing y values is the run. For example, we are going towards y is equals to 2 and we go up. So the up or downwards changing values is the rise. Okay, and the run is the values which are changing on the x-axis. For example, from -2 we go to 2. So this is the run. Okay, the changing x values is the rise. Is the run, and the changing y values is the rise. Okay, that's simple. That trick. And if we see right now -2, we assume there to be one downside. Okay, we all know that if there's nothing in the denominator, there is a one. Okay, -3 is equals to -3 upon 1. We all know that. That's basics. Okay, so we now know that -2 is the rise and 1 is the run. Okay, and let me solve this equation question first, so that we may easily draw the graph. Let me solve the whole question. So we have another thing we have to find. So right now y is equals to 10 minus 2x. Let's just copy this. Y is equals to 10 minus 2x in our modulus. Okay. First find the y-intercept. We already know the shape. When x is equals to 0, y is equals to modulus of 10 minus 0. So y is equals to positive 10. Okay. And when we have found the y-intercept. I'm getting too confused right now. And the thing is, just take out this function of x and input the value to be 0. 10 minus 2x should be equals to 0. So -2x should be equals to positive 10x. Negative 10. And just cut down these negative values. X is equals to 10 upon 2, which is equals to 5. Okay, that's the x value for the vertex. Now for the y value, we are going to say plus c, and obviously there is nothing, so we assume it to be positive 0. So we know the vertex is 5, 0, and the y-intercept is 0, 10. Okay, this is a quick graph. And now the gradient, we know, as I discussed earlier, with the x coordinate is -2. And below -2 is a 1, because if there's nothing in the denominator, there is a 1. So -2 is the rise, meaning there will be two change in y values and one change in the x values. I'm going to tell you in the graph. It's going to be much more easier there. So just copy the coordinates. Okay, so we have drawn the graph 5, 0 and 0, 10. 5, 0, 0, 10, and the gradient is -2 upon 1. So just plot the graph, plot the coordinates on the graph. When x equals to 5, y is equals to 0. We just I forgot the negative sign here. Okay, when x equals to 5, so x equals to 5 at this point, y is equals to, so when x equals to 0, y is equals to 10. These are the 2 points, and what we're going to do is draw a straight line here, and just a 90-degree angle at this point, perpendicular line. And the reason why a gradient is really useful is, let me represent this. -2 is the rise. Okay, and if we see here, if we go 2 down and 1 run, meaning one x value change, let me use it here. We are going 2 boxes down, 2 y values down, and then taking one x value. Okay, so we get this point, which is exactly in the path of our line. And if we take another point, 2 y values down, 1 x value run, and again on the point. So that's why it allows us to give the path for the reflected line. So again, we take 2 points up here. It's not important we take -2, and we just have to know the path, and it allows us to we can find it easily. Just need practice for this. 2 rise, 1 run. So it should pass through this point, 2 rise, 1 run. And I think 2 points are more than enough. And just make a line like this all the way up to point of 10. That's it. That allows us to make a perfect linear graph. Actually, no, it's not linear right now. A perfect modulus graph. So that's it. On to part F. Let me see. Let me raise this. Okay. Here now, what we need is for part F, y is equals to 6 minus 1 upon 3x in a modulus. Okay, so first of all, the shape of the graph is V shape. Y-intercept is when x is equals to 0. 1 upon 3, 0 is 0. So y is equals to positive 6. Okay, and the vertex. So vertex is, we take this whole function 6 minus 1 upon 3x should be equals to 0. So negative 1 upon 3x is equals to negative 6. Cut down these values. X is equals to 6 3s are 18. So x is equals to 18. Big value. For the y-intercept, we again have 0. So we have x equals to 18, y is equals to 0 for the vertex. And for the y-intercept, we have 0 and what we have 6. Y-intercept. And for the gradient again, for the gradient, we have 1 upon 3 is the gradient. So negative 1 upon 3 to be precise. So m is equals to negative 1 upon 3, where 1 is the rise and 3 is the run. So rise upon run, the formula fits in here. So now just plot this graph. Let me adjust the graph again up to 18. I need 18 x values. Okay, so we have set the graph and we have the coordinates at 18, 0 and 0, 6. 18, 0, 0, 6, and the gradient is negative 1 upon 3. 1 is the rise, 3 is the run, meaning the changing x values. So first of all, plot the coordinates on the graph. 18, when x equals to 18, y is equals to 0. So here's our first point. When x equals to 0, y is equals to 6. That is our second point. And it's not necessary we have to extend the graph, but right now we need more graph paper. So that's why I'm going to go on here and here and make a perpendicular line up here. So right now what we need is rise upon run. So through the gradient, we are going to find out our path. So 1 rise, 3 run. 1, 2, 3. And here is our first path. 1 rise, again 3 run. 1, 2, and 3. And I think 2 points are enough to give us a path. And we are going to make a line which passes through these points. Wait a second. Let's see. I think we need more and more graph paper for this, and we go all the way up to 6. And yes, that's it. We need more graph paper actually. In a second, from here up to here, I think yes. We need it. Yes. Wait a second. Let me first find out. Yes. So let me mark. This is the 6. We have to end this at this point. So yeah, line it, and what we're going to say is it's going to go up. Yes. We're going too much. Yes, and that is our graph. And let me make this much smaller. This is our graph for for the last part actually. So that's it. This is question 1. I will meet you in the next lecture with the rest of the questions. And that's it for today. Thank you.